Okay, now let's try applying this concept to add some more functionality to our game characters. So last time we created like a health property, some sort of attack strength property, and a defense property. And really I say property, but here in terms of classes, we should talk about them as attributes. These are all attributes. Let's add the idea of an inventory. I'm going to go back over here, and I have this class here that we started with. And we're going to use this class, and here, I'm just going to get rid of this additional spacing. Whoops. There we go. Sometimes Python doesn't like it when you paste things in. There we go. And so Woody equals character whose name is, but in fact, just to show you, notice here, like, the variable name doesn't really matter. It could be anything. It could even be dog. I'll leave it to be car1. It doesn't have to match the name of our actual character because this is one of the parameters or arguments to our constructor, to the init method. I'll call him Woody. I think the strength was 15 and defense was 7. So this works. Python 3 main.py. And I'll remind you, remember, we did have, I showed you an introduce method. Introduce method that we wrote, which would let our character introduce themselves. Print, hi, my name is plus self.name. So if I call car1.introduce, print, hi, my name is Woody. Now again, think for a second about this question. Why, and first, what is self doing here? And second, why is it needed? Like, why can't I just not have self? It's not there for no reason. Think about that for just a few seconds. Pause the video. Why is this self needed? Well, here, if I want to go print out the name of the character, that the instance, the particular object that's calling this class method, I need some way to access my own attributes. And so you could say, wait, Alex, why don't I just refer to the attribute just like that, name? Because if I'm using this class method, shouldn't this be inside of some instance? Why can't I just refer to name and it would know where to look? Well, then it would be a little confusing of, do I look in like a global frame somewhere, or do I look in the class character? And so Python wants you to be very explicit. And that's why this self is important. This tells you that I'm referring to my own self, self.name. That also means that if I just create a new variable in here, a equals 5, and I try to print out car1.5, oops, .a, notice that this doesn't work. Just creating a new variable inside of your function, inside of your method to be precise, doesn't do anything. The only way that you set it to be an attribute of your instance is by using self dot. That's what lets you refer to the actual object, to the thing that's calling this method. But we were going to add some sort of notion of an inventory. And let's say that our inventory starts off as empty. Inventory. Now, what data structure do you think would be good to use for an inventory? My suggestion is, I think we should use a list. And that's because, we don't really care about order necessarily. And so, yeah, maybe you could say, oh, maybe I'll use a set. But what if we want to allow duplicates? Like, you want to be able to have more than one apple. And so for that purpose, I think a list is good, because a set wouldn't let us have duplicates of items. And so now we can print car1.inventory. And so let's see what's in the inventory. Okay, the inventory is empty. But we want some way to be able to add to an inventory. Now, one way you could add to the inventory is to do self.inventory. And this is clearly a list. This refers to a list. Whoops, not self. Out here, you can't refer to self because you're not inside of a method. You have to do car1.inventory. This refers to a list, and we can actually append to this list. You can say, I'm going to add an apple. But that depends on you knowing what the type of the inventory is. So you have to know that it's a list. And so if I just do that, print car1.inventory, so this works. We've added an apple, But imagine, what if I wanted to use something else to represent my inventory, and I changed this self dot if I made it a set for whatever reason. Well, now by changing the internals of our class, append no longer works, because you can't append to a set, you insert into a set, or you add to a set, I believe. So here, this is a valuable lesson as you look at this, and you'll learn about this much more in further CS classes, of the distinction that you want to have between like the internals, what's inside your class, and what you let external people use. So when you create a class, you want to be very careful. You want this kind of separation of concerns. Whatever you use inside of the class should be like, it shouldn't matter. Usually you want to let people call the methods, and these methods have some expected behavior. And so it's much more rare to directly make changes or rely on the types of these internal attributes. And so my suggestion here is, how about we create a function that lets us, or a method to be precise, that lets us add to an inventory. So we'll call this add store. Let's call it store item. And of course, the first thing we have is self, always. And then the item that we want to store. And how do we store an item? Well, self.inventory.append and item. Now notice, you might say, hey, isn't this the exact same thing that we did out here? Yes, it is. But it's owned by the class now. And so nobody who's using your class has to know that item has to be, happens to be a list. Whatever collection you want to use to store items, any changes you decide to make, everything, like you can make all the changes inside of your character, and users of your character class don't have to worry about it. So we can do car1.store item, and store the item apple. And now we see the same exact output. Woody first has an empty inventory and now has an apple. And let me just illustrate exactly what happens. Now, what if I wanted to change this to be a set? Well, how do we add to a set? Python add to set. Set has an add method. And so we can now just change inside of our character class here. We would do self.inventory.add item. Notice, none of the code using our class has to change. It still works. The code still runs, and we can still see first there is an empty set, which happens to print out with set open parenthesis, close parenthesis, to distinguish it from just being a dictionary, right? If it was just braces, empty braces, you wouldn't know, is it an empty dictionary or an empty set? And now we can see a set with just apple in it. But again, I like the idea of having a list here. And so we'll keep this inventory represented as a list. Now let's try adding a few more items. Store another, so another apple and also a sword. Ooh. And now when we run this code, there's one apple, another apple, and a sword. Great, very cool. Now let's point out here, a very useful thing to see. What if I make a second character up here? So car2 goes character Picky. Picky character. I think Picky's like attack was 13 and defense was 8. Something like that. It was 12. I think it was 12. Notice, after adding to character 1's inventory, if I print out Picky's inventory, first I'll do car2.introduce so we see who this is. Look, Picky's inventory is empty. Picky's inventory is still empty. So adding to character one, to Woody's inventory does not affect Picky's inventory. Why is this? Well, it's specifically because the inventory is an instance attribute. And so each instance of our character, each character that we create, has their own inventory. This isn't shared across all characters. This is specific to the particular character we created when we, right here, when we created Woody and when we created Picky, this init method, the constructor, got run. And so, whoops, there we go. And you can see there that the Picky's inventory is still empty. The last thing that we want to do is maybe remove an item, def remove item, self item. Now, if item is in our inventory, we'll do self.inventory.remove that item. So let's see, expected indented block. Ah, there we go. So if you have that item, we'll remove it. And so if we come here and I will then do car1.remove item. I'm going to remove the sword. car1.inventory. I'll comment out car2 here for a second. You can now see after removing the sword, the inventory is now back to 2 apples. And let's just see what happens. What if I remove an apple? What will Python do? Oops, let me just run this again. Now we're down to 1 apple. So that worked great. And of course, what if I try then, one more thing that I'll try to remove is what if I try to remove something that's not there? Like a shield. Well, nothing changes, nothing gets removed because we have this nice check that makes sure that before removing any item, it actually exists, that we have it. Now, finally, a small fun thing we could add. What if we wanted to have a little bit more complicated logic? What if you could only have a certain number of items? Let's say that your maximum inventory size is like 4. So first of all, this might be a good thing to specify for our characters. So by default, we're going to have a max inventory size is, let's say 4. So you can only have 4 items. And this makes sense as a class attribute because this is like true for all of our characters. And maybe for some specific super strong character, we can override that. But for most characters, we're going to set the max inventory size to be 4. And this is almost a constant. This will stay the same for most of our characters. And so as a class attribute, we can refer to it just like an instance attribute. And we can check if the length or the size of self.inventory is greater than, is less than self.max inventory size, then we're going to add the item. But otherwise, if it's not less, we print too much stuff, can't store another item. So now, if we have space in the inventory, we add the item. But if we don't, then we don't add the item when we say that there's too many items. So let's go back here and we added 2 apples, a sword. Let's keep adding stuff and see what happens. So we add a shield, a dagger, and cloak. As I run my code here, after adding the first couple items, and I'll just print the inventory in between each. So, whoops, so we can see what happens. In fact, maybe an even better way to do this is to make it so that we print out the inventory. Inventory like this. So after adding each item, we print out the inventory. Well, you can see after adding an apple, we had apple, 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 sword, apple, apple, sword, shield. At this point, we have 4 items, and our max inventory size was 4. So when we try to store more items, we can't. So before we can store more items, we have to remove an item, and let's just get rid of one of the apples. Who needs 2 apples? And then, after removing an item, we can store a new item. Just rerun this so you can see it a little clearer here. So we had an apple, 2 apples, 2 apples and a sword, 2 apples, a sword, and a shield. But now 4 items too many. Can't store the dagger or the cloak. And so first we remove an apple, and then we store another item. And you can see that the dagger got added. So this is a fun way to implement some behavior using class methods.